Alright, hello from Hong Kong. I've been busy doing all kinds of stuff. Going up to China, doing stuff on the Bigfoot here. But if you look straight ahead, that little cabinet door is in where all the controllers are going. What I've got done here is, again, I have all the wires. They kind of come over. I've chiseled in a hole down here. I'm gonna, again, that'll get all Silcaflexed up in it. But I've to make room for the controllers, so we have, proper air. It's got to have 1 inch all the way around it for these morning stars and stuff. I've had to extend the cabinet because of the door. So, this cabinet door. I've got the shelf in. Sides are up. Now, I'm going to increase my efficiency because the wires that are here, it was like 7.1 meters is what I had for all my wires. I cut off the MC4 connectors because I had to feed them through here. But again, I've got cut another piece that's going to get recessed in here. It'll kind of have a curve here, and then this one will have a little bit deeper of a curve that'll go in there. I still have to pick up the hose for this. But everything on the inside here has been sealed. Everything is sealed off. I've got, with the Silcaflex, because the polyester urethane is going to come straight to this line, right down to here, and then I'm going to have black Silcaflex. And as you can see, just sanding off, getting the oxidation off here, you can see how nice and orange even this deck is going to be. It's just going to be a gorgeous boat. But the Silcaflex is drying now, so I'm going to let that cure. It should be till later this afternoon until it's actually cured 100%. Going to give it a quick sand, and I'm going to go over it with polyester urethane this evening, all on the inside. So tomorrow, I'm going to start mounting the hardware, and that's why this is right here. It's kind of temperate up there, as you can see. And again, when I put this board up here, it's going to hide the wires, and then down here, it's just going to kind of keep other things in. I ordered a 10 meter hose. It's a 1 inch diameter, and it's got these quick connects where you kind of. But anyway, I'll show it in the video when it comes in. But I've ordered it, and it should be here either by the end of this week or next week. But hopefully, I could do is put a little net down here, just kind of hang it, a little net bag, and just have it so you can just pull it right out, connect it, start pumping, and well, after I clean all that up. But anyway, that's a whole different song. But right now, the control, the solar charge controllers and dump load center here is nearly complete. I'm not a master carpenter, but the definition of a professional. You can fix anything you fuck up. I don't know if I can say that on YouTube, but I just did. But that is the definition of a professional, and I'm going to fix what I F up. So, but yeah, that was a goof. It was late at night, it was dark, and so anyway, but we adapt and overcome on the Bigfoot. I've got some Silcaflex in certain areas, and I've gone over on the other side. I've got Silcaflex is down here. Silcaflex is here. As you can see, I've got some plugs in here. I got one plug when I was sanding it off. It actually broke in two, and so I had to go and cut out the Silcaflex around it and pound in a new plug. So it's got a cure. I got to sand it down. But the other plugs turned out really good. Still need to put Silcaflex down there and sand down the edges. But this will be ready for varnish shortly. But the plugs are in. You can see old growth teak, new growth, very different color. And but this side is done. I've got the transition. So I mean, it'll be good tomorrow. I start putting that in. Now I ran into a problem that when I've been, I'm gonna have to turn Billy Joel off here for a minute. I ran into a problem, and one of the problems is going with connecting my Morningstar kit. What I'm going to do is, because I want to go do everything through one IP address, so it's because I want to have computer monitors, plus I have the Morningstar remote monitor, so I'm going to have two of them. So, but to get this, and I've never used the serial connectors on this. I've always, because the MPPT has always has the network, the Ethernet connection, but the pulse width modulator has a serial. So I thought about doing something different on this boat, and again, is connecting them serial. Well, as you can see with, use an example here. Here is the standard serial 9-pin connector. Well, if you look at that, it's a huge. It doesn't even fit in there because with my LEDs, and it doesn't fit. So what I've got to do is I had to go buy some short ones here, and these will fit in. And then I've cut the end off of the wire. I've cut this end off. So now I'm pinning out everything, because what I have is I've got these. This is serial RS 232 serial in, and then I'm going to go to the RS 485, or what is it, EIA 485 now, I think is what it's called, but it's going to go there. So then one of these is going to go to each charge controller, one to each dump load controller, and then I'll have another one which will be for the other MPPT that goes up for the fly bridge. So, but I'll kind of show it if you pop into the forum and you follow. It's under My Boat Systems. Historical Teak is what I call how I follow everything here. Or this is my whatever topic that's on my forum, on the Off-Grid Power and Living forum. But it has all the diagrams, and it'll go into more detail. But right now, you probably can't see what I'm talking about, and I'm rambling, and I'm probably boring you. But it's just to get the PWMs to communicate, so everything comes to the computer. So we have everything at the computer, and that's the key. So I've got some soldering of some connections and stuff to do all the serial and that, but it will be a very, very well functional system. Now these, again, when you use serial, you need, they run on, or serial to 485, or the 232, 235, you need to add power. Now these, because it's 8 volt to 16 volt, is how it works. Normally when you plug into a computer, with the old serial connectors, when you plugged in, the computer fed the power to it, just like you do on USB. But now with this, because it's just data, that's all we're passing is data, because inside this, it can log, depending on how much information you want to log, it can store up to 90 days or up to 120 days. So I'm going to have everything that it is, but I'm going to download it every day onto the computer, and I'm going to put it up to a website so that it's always accessible. It's just kind of cool, and I'm a nerd. And so I need 9 volts. So to do that, I've got, I don't know if, it's a really crappy day out there. What I've got is I've got these converters. Now what it is it's 12 volt to 24 volt DC, and it's 3.5 amps. But I can adjust it anywhere from 3 volts all the way up to 12 volts. And that, so I got 24 volts coming in, it's going to go down to 9 volt, and then that's what's going to feed these. So each of these, anyway, I'll have the European bus bar type thing, and that we're going to feed that, and so that's how it's going to power it. So then, because what's nice about the data leg on Morningstar, it is in no way connected with the control end where the power is, where it's actually taking in the solar voltage in amps and feeding it through. It's not connected. It's just kind of, they're separated. And that's why on the serial output, you need to use a converter where you can get power into it so you can pass the data to your computer. And that, so then that's going to come out. So everything this will connect to here, and then this output will go to the Morningstar. So this will kind of come out to here. Then this will go to the Morningstar MPPT. And the MPPT controller has the Ethernet connection. So then the Ethernet will go straight to my network router. And like right now, I've got, if the light is adjusted, again, I'm off grid, so I've just got the USB dongle, the GSM. It's the 4G LTE modem. But anyway, it's going to come in here, and so it's going to be Wi-Fi, and I can do everything through IP address, because I only use a Mac. I don't use PC or window-based computers. I don't use those. So, and then for my Watts view, what I do is I've got, again, the Watts view. If any of you guys use any of this Watts view, as you can see, this is also where I brush my teeth. But with the Watts view, I got 2 in each, but I got a total of 4 of these Watts view. But again, this Watts view is still the serial connector. So, but what I'm going to do is serial connection. You can run a long distance. Now this gets power from in here, so that's what actually feeds that. So it's going to pass the data, and what I've got is I've got another device here. It's a 4-port. So what I've got is because I've got 4 of these Watts views. I have 4 of these Watts views, and what it is, so all 4 of them will come in, but I've got USB out. And the reason why I got this device is, again, because it operates on 9 to 48 volt DC. So I can have that. So that's a negative and the positive, or negative and the positive. But over here, I also have a ground. And one of the concerns that I have is you're running with that, you want to be able to ground your units. So again, so you got clean data that goes through, without using ferrites and all that other kind of stuff. But again, this is going to be underneath where the computer is and stuff. So then that's going to give me, so I've got Watts view is going to give me the data for my monitoring on what's coming through, because what I'm thinking about doing is putting them in here. And so I haven't decided how the hell I'm going to get it in. But I was thinking about either putting it in here, and that, or just make another box, have it outside. But, so I've got Watts view for monitoring on my computer. I've got the Morningstar serial and EIA 485 to serial RS-232. And plus I've got the Morningstar remote monitor system, which those plug in right here, which is an RJ11 connection. So I've got 3 different ways to monitor all the power in that. And again, I am a man of redundancy. I believe I want checks and balances, especially when it comes to power. One thing, they say everything is 99% efficient, 87.9%. All these efficiencies looks really good on paper. I live in the real world, They can tell you have hot water, but if it's coming out cold, there's a problem. So I want checks and balances. So I've got 3 different ways, excuse me, to check how much power I'm making. Compare the 2, and then see what's actually in the battery bank. Because now, in addition to this, I also have a Victron blue power panel, which is going to tell me how much power, how much charge is coming in, to the batteries and what I'm actually using, so what's going out to my DC breaker panels. And so again, that's a fourth. So again, redundancy Allen at work. All right, so that's what's going on in my world. I will once I get all this kit put in, I'll make another video and I'll add it to this one. So the next video you will be watching attached to this one will be these things installed. All right, guys, be good, be safe, be well. Bye-bye. All right, good morning from Hong Kong. Now, things are starting to come together. It's going slowly, but I'm taking my time and doing it right. Okay, I have my wires coming in, and what I've done is I've just gone through the back and make it nice and clean. So I have 1, 2, 3, and 4. 1, 2, 3, and 4. So that's isolated. My ground, or the lightning protection, plus here's my main. So again, I've got the 35 mm square, what's that, like 1 or 2 gauge. And then that goes out, that comes into the Morningstar, and then from Morningstar, MPPT, then that goes out to the blocking diode. So if I have any inductive DC motors in here, this will feed it back, and what it's going to do is Morningstar says that it protects the lightning protection devices that are inside these controllers. So by having that feed through there, then we're protected. So then that comes to the fuse. I still have to go pick up I'll get that today, but I have to put in the 75 amp. That's what they recommend for this, 75 amp A&L fuse. And here's my main disconnect. So I can disconnect from the battery source to isolate it. I can disconnect from the solar panels, so it's totally isolated, so I can go work on it and not do any welding in there when I put a screwdriver in. So that's there, and then I still have to install these. I haven't gotten to that point yet. Then now the two MPPT, or no, the two PWM controllers here. Again, when the solar panels have charged up the battery bank full enough, then the solar panels will still continue to feed power in. That's when this one kicks in, and this is the dump load for that to feed one water heating element, one 1,800 watt water heating element. Again, it has 3 elements in one, but they're just in parallel. 3 600 watts at 30 volt. And again, they're at 30 volt. Resistance is set up on that way. Then now, when I have the 2 wind turbines, which is 1,200 watts maximum in perfect conditions, so that goes straight to the battery. And so there is no other controller. It's just always continuously under load connected to the batteries. So when the batteries are full, and that wind turbine still is under load, but batteries are full, this will go to the second water heater element, which is another 1,800 watts, the 3 at 600 watts in parallel. So that is my dump load, so I'm always making hot water. I'm also going to have a safety relay that's going to be connected to a temperature sensor. So when the 150 liter water tank reaches up to its peak temperature, then a relay will switch over and it will start feeding burning power off with the resistant or ceramic resistors, 1,800 watts. And then I'll show those a little later. But that's how the controllers are working. Now the networking is another thing. So I've got these watts views. Well, I've decided I'm going to put the watts view inside this. I have enough room in that, so I'm going to put that through. So when the power comes in from this, I'm going to be able to watts view monitor the power coming into my controller. And I also have the Morningstar hub here, which is going to the remote meter that's going to tell me everything that's on this, but just at that one small panel. And then the other method that I want to have is to be able to monitor it and data log, to be able to log the data, make the Excel spreadsheets and that. So I need to connect it to my computer. And so with that, I've made up these serial. This is a serial 9-pin, and that's going to go in there so I can get on the cover. That's not a problem now, because you know these ends were so big, and that I wasn't able to put it in, so I've had to resolder them. I pinned everything out, resoldered it, put a little silicone around the back so it protects it. So these are going to come to this serial connection down to the RS-485. So I'm going to have the two of these are going to be down here, and then so our serial is going to come in. Serial is going to come in on the 485 is going to go out, and the 485 connects to the MPPT controller. So these two will talk, and they'll bring it in RS-485 to this device. Then I'm going to go out of this because it has the Ethernet. So then Ethernet, I only have one IP address to see all the data that's going on in here. And that's to me that's another monitor. So I still have to hook all of this, but I've got most of the wires run. I've got my temperature sensors are going in, and now I have to have a voltage. I have to have a voltage, which is no current. There's no current, so straight from the batteries. I need to run a line up for voltage, but if I've got the MPPT plus I have the watts view that's right here, because that needs to monitor that, and then I've got these two need to monitor the voltage. So what I'm going to do is I've got these little terminal blocks here. So what I'm going to do is I'm just going to run straight down to the battery, run a lead straight up to here, so it's going to look like this is just at the battery, and then out I'm going to have the 4 lines. So I've got one more I have to run in here, but they're going to be independent lines straight off of that. And again, because there's no current on this voltage reading there, it doesn't pull any current, only just a voltage reading. Now the next set here is I'm actually going to run probably some 6 mm square wire down or 4 mm square wire down. And this is where I'm going to actually get power into here, because I need, again, for these, I need to plug in, this needs to have 9 volts, to feed it. And that's so I've got the converter, the DC to DC converter, which is going to change 24 volts to 9 volt to power these two. And then off of the same one, I'm going to come back in because I need to power this circuit board, again, because that's how it passes the data. It needs the power. So this little pin right there, that's what this round one's for. That one there is to power that. So that's going to get 24 volts. That's going to be for that. So that'll hook up into there. So then I've got power to feed my data devices, and I've got my voltage readings, temperature sensors, network cables. Everything is in here. Now what I still have to do is I still have to be able to isolate these. So because when I have these coming in, that's basically straight up from the battery with really big wires, so zero resistance. And then when they come in, then I need to bring these over to a main disconnect so I can isolate it, because the load out is just going to be the element, so it's just the load. So I need to disconnect power coming into it if I need to work on these units. So again, I don't want them to be live, so I stick a screwdriver in there, I do some welding. That's never a good thing. So, but I still have to pick up the two disconnects. I need to pick up the 75 amp A&L fuse, and we're pretty much going good. Everything is tucked behind the wall here, and once I get things kind of done, I can go and probably put another small block of that marine ply in a little box like an L shape, and I can cover up the wire so it'll look nice and clean. And I want it to look nice and clean, so when you take it off, looks nice and clean. But we're getting there. It's taking a little bit more time than needed. But and it's basically it's the data, getting these data connections and all that run in. This is where I'm running into a lot of the. I've got to resolder and pinouts. Now another thing that I'm going to be putting in, and what it is, I can show you here. I've talked about it's the Victron blue power panel. And it's called VE-NET, VE-NET battery controller. So what happens here is these little pins here, you connect wires to temperature sensors, voltage sensors, and also to your shunt. So I've got a 500 amp shunt here. So now for each battery bank, now remember I've got a port engine, I've got a starboard engine, and I've got the house bank. So I've got 3 battery banks. So I'm going to be able to monitor all 3 battery banks on this. So what is my port? What is my starboard engine? What is my house bank? What am I using? What am I putting charge into it? And also with this being on the boat, the nice thing is there's another one I can go and get for my water tanks. So I can actually go and on the same thing, it'll tell me how much water I have in my tank. So I'm going to have one of these down in the galley, and then I'll have another display up here. And because they connect all with the network cables, it's all network cables, in to out, in to out, in to out, in to out. I can have as many as I want on here. I think like 999. But I'm going to have these monitors with the shunts for the batteries. I'm going to have these for my water. And I might even do it for fuel. I'm not sure yet. Because right now, there are no fuel gauges on. I have to buy a sending unit for the fuel tanks and for the water tanks. But I do want to have one down in the galley so I know how much power I have when we're down there. And when I'm up here on the main deck by my desk where I have the other controls for this Morningstar, the Morningstar hub and all that, everything will be at my fingertips, and then plus I have the computer. So these are the devices that we're going to be putting in to monitor everything. But this one pretty much tells you your amp hours used, amp hours put into it, charged, and so will that. But I've got 4 different systems, so I got checks and balances. But other than that, I think it's looking really good. It's taken a lot more time, almost a week. Well, actually isn't a week. It's because I spent, 3 days, framing this out. Then you have to polyester urethane it. I wanted the polyester urethane. I don't want like some type of exterior home paint or anything. It's a boat. You need the paint that's designed for a boat, and so that's what we're doing. But safety is there now. When I go pick up the switches, and the fuse, I'm going to go and grab the yellow and green. I think that's 16 mm wire. And these will all get grounded, and those will go down, and I will properly ground them. So, it's getting close. Probably one more day. One full good day of work. And she'll be up and running. And then I can go and finish the shelves down in the engine room for the lead-acid batteries. Get those, run up the large cables to here, and turn it on. So once I have it turned on, they start doing inverters, etc. All right, now I'm rambling on. Enough is enough. It's time for Alan to get back to work. All right, guys. Be good, be safe, be well. Bye-bye.